Hello, everyone. This is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, Getting the Best QoE, Trends in Traffic Management and Mobile Core Optimization. Our sponsors today are Ascom, Aleppo, Enritu, Viavi, Guavis, and Flash Networks. Our presenter today is Monica Paolini, President and Founder of Senza Fili Consulting. And at this time, I'd like to pass the presentation over to Monica.
Thanks, Kyle. It's a pleasure to be here talking to you, and I'd like to join Kyle in thanking our sponsors. They've done a great job with the interviews that will be included in the report, and I will get back to that later. So QoE, it's a really hot topic now, but how I got to start writing on this, and and by the way, this webinar is a preview of the report and the interviews that will be included in the report that is going to come out next week, just ahead of Mobile World Congress. Today I'm going to give you a sense of what's going to be in the report, and then once the report is available, you will be able to download it, and thanks to our sponsors, it's free, and it will be distributed by RCR Wireless. So this is a companion report to the previous report that I wrote on optimizing the RAN. So I started working on optimizing the RAN and then moving on optimizing the core. And the interesting, the finding, or the first finding, was that it was very difficult to keep the two topics apart, because when you optimize the RAN, you need to know what's going on in the network end to end, and then the core comes in. And similarly, whatever you do in the core to optimize the service delivery has an impact and needs to be done in sync with the RAN so that you can get the best results. So to some extent, there is some common ground in the two reports, but the perspective is different. So you cannot separate the two, but there is a lot of work that needs to be done in putting the two together, in integrating it. And to some extent, it's a technology issue on how you do it, but it's also a cultural issue within the operators, where they traditionally have two different teams that work on the core and on the RAN. They need to start working more closely with each other. So that's a cultural shift. But the other finding is that as we look at how you optimize the core, the concept of QoE is really becoming central, and that's quite a new thing. And so a lot of my presentation today will be about that, and that also explains the title of the report. So let's get started. And by the way, I'm going to try to leave time for questions at the end, so feel free to type them in, and then I'll go over as many as I can and answer those that I cannot get to later. Traditionally, what has happened is that operators since day one had as a goal to make their subscribers happy. You build a network to get your subscribers to be the happiest you can possibly make them, and you run the network to that effect. So in a way, QoE has always been the focus of the optimization of mobile networks because operators wanted to provide the best service. So the question is, why has this changed? Why all of a sudden we talk about QoE all the time when we talk about how to improve the performance on the network? And I think that the difference now is that finally operators can measure QoE explicitly and use it to optimize their network, their network performance. And that just wasn't possible before. So what would have happened in a legacy environment is that operators would indirectly try to get the best QoE, but it would be done based on an element-based optimization of mobile networks, because that was the only thing that was available. So that was the best proxy to achieve basically the same goal. So the goal has not changed. The way you get to it is changing. And it has not changed entirely, or even we're just at the really beginning of the trip, of the transition. And in fact, you probably hear me talking about learning a lot, because we don't have a real ready-made solution, but we have a lot of tools that we can use to learn as we transition to a different way to optimize and run the networks. So in a legacy environment, what you do have is that operators will try to maximize throughput, minimize the latency. So basically, at each step in the network, every point in the network, they will try to get the best performance locally that they could possibly achieve across applications and everything, and that is it's good. So you try to optimize the capacity. The downside of that is that you do this in a sort of brute force approach. So you treat every packet in the same way, and by doing that, you do not extract as much value from your network assets as you could otherwise. And so now, as we move to a QoE-based optimization, operators are trying to measure and maximize QoE, paying attention what is in the performance that matters to subscribers. And at the application level, from the location at different times, and basically optimized based on that. So it's no longer pushing as much bits as you possibly can, but pick the bits that matter the most and send them first. Now, what that means is that also the way we test and monitor the network has changed. So initially, in the legacy environment, or what happens mostly still today, you test and monitor the performance of the individual network elements. You put a probe. You see what goes on at each step and optimize it, and you test it. Oftentimes, this testing and monitoring is mostly meant to make sure that the network runs at the beginning when deployed, and then monitor it when a problem arises. And this works if you have a static network that doesn't really change much through time, because you just, is it a problem? You try to solve it. But this is no longer working because the networks are becoming more dynamic. And since the network changes all the time, you need to continuously test it and monitor it, and look at it with an end-to-end view to make sure that if there is a problem from a QoE point of view, you're able to trace back what the problem is, understand it, and address it in real time. So this changes the scope and the relevance of both testing and monitoring. And in fact, testing and monitoring become pretty much a single activity, and it's a continuous one to make sure that you can optimize the network as you go along. You still have to optimize it at the beginning. So in a way, what you were doing, what we are starting to do now is on top of this. So I guess that one way to think about the evolution towards a QoE-based optimization approach is that it's not moving away from the legacy approach, but it's building on top. So all the steps, all the tasks that were here, they're still being used. And another thing here is that because of this static networks and trying to maximize capacity, the RAN and the core were kept separate. Now, this separation doesn't work anymore, as I told you before. So there is a need to integrate RAN and core. And sort of as a consequence, you'd have the legacy optimization based on historical and average KPIs that will provide a view of how good the network was you optimize those to improve performance. Again, in a network that changes dynamically, that's still important to capture the overall trends in network performance, but you need to do more, and you need to look at real-time, location-aware, application-aware QoE data. So what I'm going to talk about, what I'm going to do today is to basically go through first talk about elements that matter, that are driving the change, which is basically a set of dimensions where the QoE data, through which the QoE data is defined, and that become important and provide a way to differentiate traffic so that you can optimize on the basis of QoE. And then different ways in which we can go to ensure that this information, the dimensions of information that define QoE are taken care and used for optimization. And then at the end, I will go and give you a quick introduction on the interviews, so that I still hope you will read them, but I will just go through a quick summary of what the main topics were. So what is driving the change here? So until recently, as I said, operators were trying to maximize capacity. So as long as everything was well behaved, there were no, malfunctioning items. You just push whatever content you could accommodate. But now we're moving towards that. Capacity is still clearly important. Capacity, speed, latency. It's not like they're important as it's reduced in any way. But it's not just about that. The crucial thing is how the capacity is used. And now operators have the tools to choose how to use the network resources to fit their strategy, and then basically prioritize the way they use those resources. In doing so, what's interesting is the marketing and operations increasingly converge. So it's not only the RAN and the core people that have to work together, but the marketing and the operations people that need to work together, because this is a very crucial tool in the revenue generation or creating revenue opportunities lies, so that operators can create and deliver services more quickly, and that ties back into the marketing part. So the marketing and operations can work together to improve the opportunity to create new revenues. I think that in all this, the differentiation that we see in traffic, which is what I'm going to cover here in the first part of the webinar, is it's an increase in complexity. So the downside of this is that the traffic is becoming more complex. There are more things to keep in mind. There is more data to analyze. So all of this adds to the complexity. But the complexity in itself, it's actually a good thing, because it creates the need for innovation, but also it creates the opportunity. Because it's only when you have diversity out there that you can prioritize things as needed. You can think about it in the way it happens, for instance, in the real estate market. Right now, in the mobile world, the way services are priced in most markets is as if you sell houses just based on size. It doesn't matter what the neighborhood of the house, the quality of the house, or anything. It's pretty much, you pay by size. And if you do that, you're bound to leave a lot of money on the table, because everybody pays the same. There is no, there is no variability. So the people with a lot of money still wouldn't spend that much money, because they don't need to have a huge, the size of the house that they want is going to be just that much. So they don't have the opportunity to spend more to desire a house that is more expensive. And I think that the complexity here basically creates a market where which is similar to what you have in real estate, where there are some houses that are more expensive because they're in a better neighborhood, because they're, built differently, or, and so you create the differentiation, but you don't only need to have the differentiation out there, but you need to also manage traffic accordingly to that, according to that differentiation. So this is important, I think, not only because it allows you to use the your network in a more efficient way, but also because you can extract value from it. So this, I'm going to go through all of this rather quickly because I think it should be pretty clear what it is, what is it I'm talking about. But fundamentally, the thing to keep in mind is that QoE, it's not it's not something like when you look at voice, you have a MOS score, you have a number, which is subjective, but it's one number, and it's it pretty much tells you all. When it gets to QoE, there is a lot of variability. There is a lot of factors that impact it, and so ideally, we would want to have an objective, a very simple way to capture it. But in practice, there is a lot of variability, and the performance of the network depends on many variables, and they need to be taken into account when you optimize the network, because the network is at the end constrained in terms of capacity. Even if you go to, if you go to 5G, you build a network to capacity. So there is always, you always try to squeeze as much as you can. And so as you do that, you have to take into account the experience of the user in the context of many other dimensions. So time is one of them. So here, the difference, the usage is different based on the time of the day. This is just the new data from Cisco VNI, and it's interesting because you see there is the clear curve that you're familiar with, but that really hides a lot of the variability that it's in there, because this is averaged across a market. But if you go and look at specific locations, you would see that there is much more variability. So if you look at the downtown area, you'd have, probably around here, you'd have a peak when people get out of work, and that peak is sort of, you don't see that peak here because you just look at the overall pattern. Cisco thinks that the peakiness might increase. I think that you can argue both ways, but it's not clear. It might not increase, but still at a local level, there is going to be a lot of variability. And then there is also the spikiness, that it's at the millisecond level, which is due to the fluctuation in traffic. So it's not a question of demand per se, but it's just the nature of the application. And this pattern interacts with location. So it's not just time, but it's not just the location, but also time. You can look at this in Tokyo. There is a movie that goes with this, and you can see how much this pattern changes through time. You can think about, we just had the Super Bowl. It's there are all the pattern really depends on location, and the kind of QoE and the kind of performance you get. It's highly dependent on location, and the areas with extreme traffic are very few, but that's where the value, where as a subscriber you value the service most. Another thing is devices. Now, the clear scope for growth is on the other devices, on non-cellular or, non-phone and non-laptop devices. There's just so many people out there. A lot of the world has already a phone, so there's just so much growth that is the potential for growth in mobile phone is limited, but there is all the new IoT devices, and they create a lot of opportunity because it's a very different service, but at the same time, it's to optimize the network for those devices as well is going to be a challenge as well as an opportunity. And then we have applications, and clearly here, the growth area is video. Video is growing a lot, but I think that we should start thinking of video of not just streaming video. There is going to, there is, and increasingly even more, there's going to be conversational video, streaming video, and broadcast video, and they all have different requirements. Same thing for voice. We don't have just VoLTE and obviously circuit switch, but also we have Wi-Fi calling, and again also OTT, voice over IP. So again, there is more differentiation in terms of traffic, and when you think of from the point of view of optimizing the network, it makes it more complex to understand what the relevant QoE metrics are and how to use them. So for instance, for video, there are different elements that come into play. How do you define if a video is good? Is it the stalling, the quality, the resolution, the time it takes to start? They're all important, but how are they important? And for different people, they are important in different ways. Now, if you look at the overall application market, here we see there's also a lot of fragmentation. The top applications are well known, but when you go down the list, there is a lot of applications with different requirements as well. RAN condition is another element that it's very important. So traditionally, from a core point of view, you try to optimize core performance. But in order to do that, if you know what's happening in the RAN, what are the RAN conditions, what is the interface you're using, how loaded it is, are you indoors or outdoors, is it a small cell, macro cell, a DAS? All of this have a bearing into how you want to optimize the traffic from the core point of view, how you want to allocate resources. So taking into account that information in the core is quite important when you want to optimize it. And again, this is to some extent independent from the QoE, but it's all sort of it's all related. One of the main complexities of using QoE information to optimize the network is the fact that QoE does not linearly relate to the performance of the RAN or any other element in a reliable, in a consistent way. So you might have a bad QoE at the handset level. So you're trying to watch a video and it doesn't work. It could be a problem with your phone. It could be a problem with the RAN. It could be a problem with the backhaul. It could be a problem with some element in the core network. It could be, you could have a signaling overload, all sorts of things. And but they might all sort of display, or they might all be seen from the user in the same way. So the user doesn't know, and so if the user were to say, is it good or bad, they would have the same answer, but the cause could be many different things. In fact, you might have a situation where everything apparently works well, but the performance from the end user is nevertheless bad. So let me move forward. Okay, policy. Policy is the last element that matters, and this is interesting in many ways, because the policy is something that you traditionally set independently from the QoE, but there is in many ways the policy and the QoE-based way to optimize the network are really closely linked. And this is because policy allows you to link the optimization efforts to monetization. And that's really crucial, because at the end of the day, as an operator, you want to keep your subscribers happy and generate a profit at the same time, and trying to put the two together. And policy is really the link that allows you to do that. But at the same time, you don't want to think about the two as being disjoint. A policy can benefit from knowing what the QoE is, so that you can refine how you set policy. And then the policy itself allows you to optimize the network with a view to improving network utilization, well, extracting value from your network assets. And I'm going to talk a lot about, doing everything in real time. And but policy clearly is not something you set in real time. Policies has a longer time frame. But what it does in real time is it creates the framework, the infrastructure, so that you can do the real-time changes that are based on the policy in real time. So it is really a crucial element here to tie everything together. And I think that that's really the challenging part. At the same time, as as I have the opportunity, but also the challenging part is to have all these different elements, all these different dimensions, all these different sources of information to come together, and that's the complexity. And this is what I'm going to talk about it later. And then now is to look at the way forward, which is now that we see that there is all this complexity from a data point of view, now that operators realize that they have all this data sitting there, how can you use it? Just because you have the data there doesn't mean that you can use it. As much as it's difficult to capture QoE, as much as it's difficult to optimize the network in real time, the information is all there. The operators have all that information in their networks. The question is how to extract that information, how to get to the relevant information, and how to use it to improve network performance. So the very first challenge is, okay, we want to, from an operator point of view, you want to focus on QoE, use QoE to drive optimization. However, QoE is subjective. It not only is defined in a subjective way, but for different people, what good means to different people is different. And what is good for them depends on the context. So depending on where you are, you might be willing to accept different levels of experience. So for instance, you're in the Super Bowl, if you realize that everybody's trying to use the network and so the network is slower, you might be more accepting of that than if you are at home and and some regular time and the service goes down, and you might question why is the quality not good, or if it's reliably bad. Now the QoE also depends on the application. So for instance, if you have video or even more so voice, you're much more sensitive to latency and jitter than if you are browsing the web or texting. The QoE, it's effectively something that it's perceived on the device side, but it's also very difficult to measure anything on the device. There are privacy concerns on top of everything, but you want to measure QoE from the network as much as possible. So you need a way to relate QoE to network performance. So you need to have a perspective from the device, but a lot of the data will come from the network. And so and you need to trace back the cause of a problem. So you need to have an end-to-end view of the network, of how it's performing, how that is impacting QoE, and then if there is a problem, try to go back and understand where in the network you need to do something, what action you need to do to fix that problem. Now, one other difficulty in measuring QoE is that there are, for a lot of data applications, there are no standard metrics, and not only the QoE is subjective, but how you measure it, it also, there are different metrics to use. For instance, for video, what's the relevant one? Is it latency, stalling times, the time it takes to get started, the fact that the video doesn't go through? So it's all variable. And in an IP environment, there is a lot of variability in performance. And so this is really a learning process, and I think that what both operators and vendors are doing right now is to try to learn as much as possible, and we have the tools, but at the same time it's going to take some time to refine and to get a good understanding, so that I believe it's going to become much clearer how to act on early signs of potential issues. Another one is the need to do all of this in real time. Because the composition of the traffic changes, because of the networks change, especially with with the addition of small cell CRAN and other or the use of unlicensed spectrum, the networks, the way that the traffic is routed, the way the composition of traffic changes continuously, the QoE is also going to fluctuate much more. And so what happens is that you need to make those changes in real time to really be effective. You still need to do the long-term changes. You need to optimize for the long term, or plan for capacity expansion, and all that stays there. It doesn't go away. But on top of that, you want to optimize in real time. And so the question is how you do it. And one way is that you need to constantly monitor and have a more end-to-end, in-depth view of what goes on in the network at all time. And this allows you to find out what goes wrong possibly ahead of time, before it happens, to see the first signs of a problem is arriving, so that you can predict what goes on, and take care of any potential emerging problem before it affects the subscribers. But basically, testing and monitoring are no longer an external activity, but they really become part of the operation. So they become much more integrated with the orchestration of the network and the fundamental running and optimizing of it. Now, said that, the question that often comes up is also about what is real time. How close to the millisecond do you need to be, basically, to call something real time? And I think that this is a very important question, and it's important to answer it appropriately, in the sense that for different tasks, different time resolutions are appropriate. And if you go to a situation where you just try to go down and down to as close to the millisecond level as you can, not only you don't gain anything, but you just generate too much complexity, too much overhead, and at the end you're not getting anything out of it. So in the move to real time, you have to be careful of picking the definition of real time that it's relevant for you, for your application. So it is important to understand what is that you're trying to achieve and what kind of depth you need to go into. And same is not just for time, but also for detail. You don't want to be too detailed. You don't want to be not have enough detail. You need to get the right level. And this is actually what the analytics helps operator doing as they deal with big data. So they have huge amounts of data that they need to look at, because they don't only need to look at the performance level, but other information that we saw, like, for instance, a location, where the subscribers are, what application they're doing. So there are different ways to basically horizontally look at the data, so you can go deeper depending on the need. So it's important for the operator to have the ability to go deep, but at the same time, you don't want to go deep any more than you have to. So it's really crucial to the success of the transition to a QoE-based optimization to have a way to make sure that you have access to the data when needed, but that you're not overwhelmed by it. And so and it is important to first start with an end-to-end view of the network, look at what goes on, identify the problem, and be able to then focus as needed and have the agility to do so. Now, agility is one element, but the other, at the same time, you also need automation, because you cannot have a sufficient number of people that are there looking at every single thing that happens into your network. So all of this has to be automated. And so this is really a crucial tool in order to enable all the changes, all the shift to a QoE-based optimization that looks at different dimensions in traffic. Now, the next one, again, sort of we're drilling down a little bit too here. It's virtualization. Virtualization allows you to act on the suggestion that the new testing, monitoring, and analytics give you, because if you, as an operator, you know that you can do and you should optimize your network in one direction in real time. You need to be able to act in real time too. And what virtualization does is to give you the opportunity to adapt to a dynamic environment. So I think that what we're seeing here is that these changes happen at the same time because they're mutually enabling each other and mutually reinforcing each other. So that with virtualization, you are in a better position to access and use this new set of information that you have, is QoE or application-based, all the different things we discussed before, and at the same time it provides an additional reason to move to a virtualized environment, because you see what is that you can do that you couldn't do before. So it's something that it's just a mutual reinforcement type of situation, and so. But at the same time, when you have this kind of environment, a lot of things are working differently. So, for instance, physical probes that used to be very much important, and they're still important. Again, this is sort of in addition to what we had before. You cannot, in a virtualized environment, some places you can have some physical probes, but you also need to have virtual probes because you want to measure performance where needed. You also need to have more active types approaches to testing, where you you simulate data, and what that allows you to do is to focus on specific areas where you have a reason to suspect that there is something that might be creating a problem, or already creating a problem, or create a problem in the future, so that you can target. So you can target in terms of focusing on different parts of the network, simulating data, reproducing the problems. So it's a much more active way of controlling or having a sense of having a view of what the network does. It's not just by letting the network tell you, oh, there is a major problem here, but as an operator, you try to understand and investigate things before they happen or as they happen, so that you can react to that. And that requires a lot of flexibility that virtualization will provide, but also will require a different way to run the network. Now, end-to-end integration is another interesting aspect of it, and this is what I was talking at the beginning, is that the traditional separation of RAN and core optimization, or RAN and core elements of the network, is no longer works. The two are becoming more dependent on each other, and the boundaries are disappearing, and that's good, because you can optimize for both at basically the same time, and then you can have you can use your resources more efficiently. But what this does is, it doesn't mean that everything is going to be more centralized with virtualization and with the sort of the blurring of the boundaries between core and RAN. But it gives operators the freedom to pick the location that they want. So some functions are becoming more centralized, and some are becoming more distributed. And that's quite interesting, and that's very again, it syncs well with the interest in QoE, because depending on what you're trying to achieve, in terms of maximizing QoE, some the functionality might be more maybe advantageous to have some functionality to be more distributed. And as I said before, this is a change. It's not just an organizational. It's not just a technical change. It's organizational as well. And the interviews that we have in the report talk a lot about this need to get the different teams to work together in ways that they're not used to do in the past. Now, the final thing here is that as you get end-to-end integration, instead of looking vertically at different elements in the network and optimize their performance, what operators are starting to do is to look at the horizontal functional splits, so that you can optimize the network based on different slices, and each slice has a different carries a different type of traffic. So this is a way to think about it, that it's a new way to basically operate the network. And finally, the mobile edge computing. It's an interesting new development that puts all of this together. So you have the virtualized mobile network, RAN and core, are with mobile edge computing. Have a way to put the functionality where needed, as I was just talking about. So basically, MEC pushes the core functionality to the edge close to the RAN. Now, when that happens at the same time, when you have a CRAN or a vRAN architecture, you see that the edge is moving towards the core and the core towards the edge. And oftentimes it makes sense to have functionality co-located, especially for video and other real-time traffic, because this approach allows the network to have a better throughput, lower latency, and more scalable networks. So this is all. And so what I'm trying to get here is the fact that you have a much richer set of data that you can use to optimize the network, that allows you to do much finer work, much better work at optimizing the network. But at the same time, there's a lot of learning to do, and there are a lot of tools that are out there. But we also have to realize that this is really the early days, and it's very encouraging to see that operators are really committed to that. But at the same time, it's also true that we do not have, well, not only we do not have the clear answers. It's not like you have an LTE specification, and you know what the network does, what are the requirements, you go ahead and you deploy it. There's not quite anything quite like that. It's more, we have the opportunity to do something, we have to learn how to do it. And it's not a specification, it's a choice, it's a strategy that operators have, and it's a way for them to differentiate from each other. So it's a huge opportunity, but it's also quite a lot of work. Now, said that, I'm going to give you a very quick preview of the interviews. The interviews in these reports are quite important and fundamental, because the report talks about the high-level trends, but then in the interviews we have a way to see how those trends take place. Are actually used or implemented in different products or by different companies or different operators. So it's really just allows you to go to go down deeper in specific areas. So I'm going to just give you a very quick overview so that there is time for questions, but do read the interviews. The interviews are already available for download. So the first interview is Aleppo, and we talked about service creation, monetization, and policy. As I said before, policy is an essential link for optimization, even though we might not think of using policy for optimizing the network, especially when you think about the RAN. But I believe that it's absolutely crucial to establish the link between optimizing the use of resources, extracting as much value, and keeping the subscriber happy. And that's really what at the bottom of all the monetization efforts is. Then we talked to Aritsu and looking at QoE and try to understand how how to capture the QoE, because what is good experience, what is bad experience, and so it's again, this is as I said before, it's really not trivial. So you need to have a combination of extracting the best data you can from the network, the data that's relevant to you, and then have the analytics to look at it and analyze it. As network testing, here we talked more about the testing and monitoring and how you can have a more active approach to it, and emulating the data so that you can explicitly test and explicitly go and look for specific issues. And that's a very powerful thing to do, especially if as you try to predict, anticipate the emergence of potential issues and take care of them before they happen. With flash networks, we talked about how you optimize what's happening in the RAN from the core. So it's basically trying to increase the network utilization, the performance in the RAN as you move from the core, and try to optimize the network so that by the time it reaches the RAN, you have an easier job there to transmit the data. Guavus is, I talked about analytics before. That's what they work on, and they are really, we talked to them about how you do it, how you find the information that it's relevant to you. And this is really a crucial issue when you're dealing with big data. You have so much data. How do you find what is important to you so that you can actually find a solution to whatever problem you have in the short time? And how can you avoid not having to look through data continuously? And the final interview with the sponsor is with Viavi, and here we looked at how you go from the end-to-end view of your network that you need to have first, and how you can then go deeper as needed to identify issues. And I think here we talk a lot about the multidimensionality of the data that you're dealing with. The more data you're able to combine as you optimize the network, the more efficient you can be. But you have to do it properly, otherwise you're just submerged by complexity. And then finally, we talked to two operators about their experience. Through UK, I talked to Moni, and he has the best title. He's the head of network perception, and it's actually I think it's very fitting with what we talk about. It's a perception of the service, and that's really a good way to look at it. How do we improve the perception? So I think that calls attention to the fact that it's more than just performance, it's more than just bits. And and the question here that we discussed a lot is, how do you put together the profitability, the happiness of the customer with the network performance? Things like throughput, latency, and all that. How do you establish the link? And then with Adrian at Telefonica Argentina, we talked about the need to have an end-to-end approach to optimization. So QoE is important, but you also need to relate it to the whole network end-to-end and understand if there is an issue, how to improve it, and from a revenue point of view, how to improve QoE, and then, well, what QoE is, and move it back and try to understand what to do in the network. In order to do that, you need to have RAN and core people talking together, and the RAN plus core people talking to the marketing people as well. And that's, we talk about how they have done that at Telefonica Argentina. And I think that's all from me. So the report is going to be out next week, and you can download it for free. And now I believe we have some time for questions. So Kyle, back to you.
Thanks, Monica. Yeah, so we've had a few questions come in, and any questions anyone has, please submit them via the Q&A tab. So first one we had was, given all of this on the quality of experience and operators' ability to offer quality of experience, will operators then also be able to address specific verticals with tailor-made KPIs and SLAs?
Yeah, so I assume you're referring to verticals, so IoTs and the machine-to-machine services, right?
Yeah, exactly.
Yeah, actually, I only briefly touched on this when I talk about the devices, but this is actually a key driver. Well, it will be a key driver as you optimize the networks in the future. Right now, it isn't, because there's just so much IoT out there. But as you move forward, one way to think about IoT is that it is going to increase further the diversity of traffic and the diversity of the devices that you have out there. So for each IoT applications, you're going to see a different type of device, a different type of requirements, and all that. And so what that what a QoE-based optimization approach allows you to take all these differences into account and provide a different service, SLA and all of that, to different applications on an as-needed basis. Now, I don't know whether QoE is the best term here, because when you have a sensor, it's not a quality of experience per se, but it is kind of you can think of it as the experience, well, not the experience, the performance for that device, for that service. So operators will have the opportunity to differentiate on both ends. So you might have an IoT service that is very has very low requirements in terms of low throughput, low latency, and but at the same time, it's an application for which they can only extract so much in terms of revenues. So it's a revenue constrained, but also doesn't have huge requirements. And on the other hand, you might have an IoT application that is mission critical and uses a lot of throughput, and whoever is interested in that is willing to pay more money. So by doing this, by managing traffic in a more active way, you can accommodate the two. And you can use, for instance, the times in the network where you have more capacity to transfer to transmit all the data for the low requirement, high latency type of application. So you can put together different services over the same network in a much more efficient way. And obviously to do that with the usual subscriber market, so like the smartphones, tablets, and things like that.
Right, that's great. So the next question we had come in, it's pretty poignant. So what are the 3 most important things operators need to do now to correlate their QoE to network performance?
The 3 most important things. I think that I would say that the very first one is to try to capture QoE based on the application and traffic type, because the way we judge performance from the subscriber point of view, it's really highly dependent on what we are trying to do. And again, it's not just video versus web browsing. What kind of video is it? Is it conversational video? Is it streaming video? So I would say that the ability to look at the application level and traffic type level is crucial. The other one I would say is to look at the location of the subscriber, depending on where you are. Well, I guess I would say location/time, the combination of the two. The kind of performance that you're going to be able to provide to the subscriber is different. So if you are in a situation where you are in a deep indoor location, well, you're going to be constrained. You're not going to be able to have top speed. On the other hand, if you are peak hour, same thing. So that's another crucial thing. Third one, I guess that the other one would be, well, possibly to understand more about the device, because that's also another element. So if you look at the subscriber point of view, and that, I guess it goes more into the service assurances to, if you know that there is a problem, make sure that the device is not being the bottleneck there.
All right, thanks. So we have a couple more questions here to get to. So is virtual core and RAN necessary to achieve better QoE and small networks and DAS systems?
So it's a question of what is different from small cells and RAN, small cells and DAS?
Yeah, what role does virtual core and RAN play in QoE for small cell networks and DAS?
Yeah, if you have a virtualized RAN,
right.
Well, yes, that is going to make it easier to act on any potential QoE issue. So on one end, if everything works fine, it gives you more flexibility to allocate resources. So you're in a better position to change the network, so the network is more dynamic, because you can direct your resources where they are most needed. But also in real time, it allows you to to address any issue in a much faster way, because all the elements in a virtualized RAN are much more closely related to each other, working with each other. So it's easier to change the parameters of the network, so that you can adapt, you can more quickly react to any issues that arise in that case. And then with MEC, where you have much more functionality, so it's basically what we used to say, more intelligence close to the edge. But basically, when you do more processing at the edge, then you have a better way again to control. So you have more control over the QoE in that way.
All right, thanks. That's about all the time we have today. I want to thank everyone for attending today's webinar, Getting the Best QoE, Trends in Traffic Management and Mobile Core Optimization. Again, sponsors of today's program was Ascom, Aleppo, Enritsu, Viavi, Guavis, and Flash Networks. And again, thank you to our presenter, Monica Paolini, President and Founder of Senza Fili Consulting. Thank you, Monica.
Thank you, Kyle. It was a pleasure.